Okay,
page 88. I need everybody's attention so we can get as much done as possible in the 45 minutes we have left. Okay, let me look over at 88 and see what we were doing on page 88. We were finding asymptotes and finding asymptotes. Alright, so we're finding asymptotes on page 88. Any questions on page 88? Motion?
50 to 54.
50 to 54. Imagine that, there's some trig in there. So the limit as x approaches pi over 2 from the right. Of -2 over cosine. Alright, so number one rule in finding a limit.
Plug it in.
Plug in. So the first thing I'm going to do is plug in pi over 2, which gives me cosine pi over 2. And from memory, we should know that cosine pi over 2 is a quadrantal, which means my only three options are
0,
0,
1,
1, -1. So where's pi over 2 located?
90.
90. So what is, since it's cosine, what's my x value up there?
0.
0. So that means it's 0. So I get -2 over 0. So what does that mean I have at pi over 2?
That's not here.
I have an asymptote. So I have an asymptote there. So technically, the limit to this does not exist. But we're going to figure out where it's going. So we're going to say D and E going to, and what are my two options if I'm approaching an asymptote? Infinity or negative infinity. So I need to know if this is going to infinity or negative infinity. Okay, so we're doing the right side of pi over 2, which means I'm just bigger than pi over 2. So if we're just bigger than pi over 2, what quadrant are we in? We're in the second quadrant, if we're just bigger than pi over 2. And what is cosine in the second quadrant?
Negative.
It is negative. So that puts a -2 over another negative, and the combination of those two gives me a positive, so that means we are going to infinity. Okay, so
Not 0?
say it again.
Oh, that says 2. Okay.
So, what did we learn there? What did we figure out?
Got pi over 2 is 90.
What did we this whole statement right here, what did we figure out?
That there's an asymptote, but it's going to infinity.
It's either going up or it's going down. So there's an asymptote at pi over 2, and as I approach that asymptote from the right side, what's my graph doing? It's going up. Let's verify that. Alright, so we got -2 over cosine of x. Alright, so control, divide, I've got -2 over cosine of x. So when we graph this, approximately what's pi over 2 going to be? How much is that going to be on the scale of the calculator? It's scaled in 1, 2, 3, 4. What's pi over 2? Where's pi over 2 going to be at? How much is pi? 3.14, and 2 is less than that, so it should be between what two numbers? 1 and 2. So there should be an asymptote on this thing between 1 and 2, and on the right side of this asymptote, where should it be going? It should be going up if we did it correct. Okay, so pi over 2 is right here, and on the right side, my graph is headed up like this. Okay, so that's what we're figuring out without the use of the calculator. Alright, so let's look at another one of those. Limit as we approach 0. So this time 0, x plus 2 over cotangent. Okay, so number one rule is plug in. So I need cotangent of 0, and cotangent is made up of cosine over sine. So in the top, the top is going to be 2. So what is cosine at 0?
Like, oh,
1. So it's going to be 1 over 0 down here. So what does this end up being?
2. 0.
Ends up being 0. Because this is 2 divided by 1 over 0, which is 2 times 0 over 1, which gives me 0. Yes.
So, is it okay if we like split cosine and sine up before we plug in 0?
Yes.
Okay.
Because what's the definition of cotangent? Cosine over sine. So what's cosine at 0? 1. And sine is 0. So that's how I get 1 over 0. So I have 2 divided by 1 over 0, which gives me 2 times 0 over 1, which gives me 0. So that means as I approach the x value of 0, what should my limit be? I should be at 0. So let's graph that as well. So x plus 2 over cotangent. So x plus 2 over trig cotangent. Was it just cotangent of x?
Yes.
Okay, so when I graph this, what should be happening right here at the origin? I should be crossing at the origin. Because we said as we approach 0, where should we be?
0.
We should be at 0. So if we did that correctly, we should be crossing at the origin, and we are. Okay. So that's what we're doing there. All right, so there's one more, 54. So 54 was the limit as we approach 1/2 of x squared tangent by x. Okay, number 1 rule of finding a limit.
Plug it in.
Plug in, so if I plug in 1/2, that's going to give me 1/4 tangent of pi over 2. So we're back to pi over 2, which is straight up. My ordered pair straight up is 0 and 1. Tangent is made up of what?
Sine over cosine.
Sine over cosine, so that means it's going to be 1 over 0, correct?
Mm-hmm.
Okay, which means I'm dealing with what?
That's not exist.
It does not exist, so I'm dealing with an asymptote. So I know this is D and E. Okay, and then we want to see if it's going anywhere. But I'm going to have an issue with this one because it's just 1/2. It's not 1/2 from the left and from the right. So what do I have to check? I have to check both. Bless you.
Bless you.
So we were at pi over 2. So pi over 2 on the left. What quadrant are we on?
On the left.
It's first quadrant, and we know it is
Uh,
positive. So from the left, we're going to positive infinity. Okay? If we go on the right, where are we at?
negative.
We're in the second quadrant, and tangent in the second quadrant is negative. So on the right side, I'm going to
Negative.
negative infinity. So I'm going to negative infinity on the right. I'm going to positive infinity on the left, which means what? It means I cannot describe where this thing is going. Okay? So on this one, all we can say is D and E because we're not going to the same place. So let's graph that so you can see. So x squared tangent pi x. So control dot graph x squared tangent tangent of pi x. What did I do?
Oh, we can't because from the left it's going down and from the right it's going up, so you can't describe where it's going.
Totally. Obviously, I'm trying to solve this.
So when I graph this, at the x value of 1/2, what should I have?
And that's
I have an asymptote, and on the right side we said it was going,
no.
right side we said negative infinity, and the left side we said positive infinity. So it should be going up on the left and down on the right at 1/2. So 1/2 is right here. So if we did it right, it should be going, what did we say? Up here, and it should be going down there. If we did it right. And as you can see, here's 1/2. On the left side, I'm going up. On the right side, I'm going down, like we said. So since we're going 2 different places, I cannot say that it's going anywhere since we're not going to the same place. Okay, if they told me the right side or the left side, then we could have given them a better answer. But all we can say in this case is D and E. All right, anything else on page 88? Clear some things up, Bruce? Yeah. Anything else on 88? All right, let's move to 205. All right, on 205, let's see, we did 20 to 34. We are finding limits as we're approaching infinity or negative infinity. So what is it we're concerned with if our limits are approaching infinity or negative infinity?
The denominator?
Not just the denominator.
Oh, the exponent.
We're looking at the exponents of the numerator and the exponents of the denominator. If my exponents are the same, how do I get my limit?
Right.
Take the coefficient. If the bottom's bigger, it's 0. If the top is bigger, it's D and E, but then we want to determine if it's going to infinity or negative infinity. So those are our 3 options whenever we're approaching infinity or negative infinity. So, questions on 20 to 34 on page 205.
26.
26. Alright, 26, we have the limit as x approaches negative infinity. Of 1/2 x minus 4x squared. Okay, and you can do these in one of 2 ways. You can find the limit as it sits right now, or you can combine those 2. Okay, what do you guys like to do? As it sits. So that means we want to look at each one of them separately. So I want the limit of this one, and then I will subtract the limit of that one. So, which situation am I dealing with on 1/2 x? Which one of the 3 situations?
Same or bigger exponent on top.
I have a bigger exponent on top.
So the x goes on the top.
So yes, the x, if it's like 1/2 x, that's the same thing as
X over 2.
x over 2.
Okay.
Okay, so that means I'm bigger on top, which means it's doing what? It does not exist, but we can tell it's doing what? Negative infinity or positive infinity. And to figure that out, we just plug in the negative, which makes this negative, so we're going to negative infinity right there. Okay? On the other one, what situation do I have? The bottom is bigger, which means it is 0. So I have negative infinity minus 0, which is negative infinity. So technically, the limit does not exist, but we know it's going towards negative infinity. Yes. Because there's no exponent, there's no variable in the bottom. There's no variable in the bottom, the top has to be bigger. So if I were to graph this, what is this telling me about my graph? As I head out to the left, my graph should be going down. That's what this tells me. So we'll graph that real quick. So somebody help me with that. So control dot 2, it was 0.5x minus 4 over, got it? 0.5x minus control divide 4 over x squared. Is that correct? Okay, so we just said as it goes out to the left, it should be going down if we did it right. Notice, as we go out to the left, what's my graph doing? It's going down. Okay?
Does it matter which left which like the left from 0?
The farthest left.
Okay.
The farthest left is what we're talking about.
Okay.
When you're approaching infinity or negative infinity, you don't want it farthest left or farthest right.
Okay, that's not anything else.
In the middle, I don't care about. I can't figure out anything in the middle. It's just the outside. Anything else? 205. 28 to 38. Anything else? Or 20 to 34, sorry. Number 20? Okay, 20 is the same situation. If I look at the first one, what's 5 over x? Which situation is it? There's no variable on the top. It's got to have a variable. It's got to have a variable and have an x on it. If there's no variable, there's no x on it. Bottom's bigger, so that means that one's 0, and on the second one, does not exist, and it's either infinity or negative infinity. And what happens when I plug in the negative infinity? It's negative, but then there's another negative in front of it, so it's going to end up being positive infinity because the two negatives cancel out. Anything else? 20 to 34.
So whenever you compare your answer on one to 5, like that's not existent. So like the number, like what like that.
Like on 20, I would say it does not exist. My graph is headed towards infinity.
But on one, we're like one do you want like whenever they're equal, you put the coefficients, right? Would you put that as your answer, or would you put the negative and positive infinity?
And if they're the same and you put the coefficients, then whatever your coefficients are, that's your answer.
Okay. Alright.
I only put infinities if it does not exist.
Okay.
Anything else on 205, 20 to 34? Let's jump over to page 80.
You know I did do this. I have number 80.
On page 80, we did 84, 86, 92, 94, and 95. Questions on those 5 problems?
84,
86.
86, both of those.
F of x equals negative 5 over x. And plus tangent of Alright, so we're trying to prove that there is a 0 on this given interval. So what is our first step when we're trying to prove there's a 0 or a certain type of number on an interval?
Find f of 1 and f of 4.
We need to find our function values. So the very first thing you do is plug in your function values. If I'm grading this on the test and you find the function values, you're going to get the first point. So the first point is going to come from finding the function values. So I stick 1 in there, that's negative 5 plus tangent of pi over 10. If I stick 4 in there, that's negative 5 over 4 plus tangent of 4 pi over 10. Now, since pi over 10 and 4 pi over 10 are not special angles, you can use your calculator on this.
Okay.
Okay? So,
Why are we finding those?
because if I'm going to prove there's a 0, I have to look at the y values of my inputs.
Okay.
I need to find the y values of my inputs.
Okay.
So that's the first thing I need to do. So negative 5 plus tangent of pi divided by 10. Alright, so I got negative 4.675 there. On the other one, I have negative 5 divided by 4 plus tangent of 4 pi divided by 10. And on that one, I got 1.827. So, when you're working this problem, your first points are going to come from finding those function values. What's the next thing I need to consider? If it's continuous on that closed interval, okay? What's the thing that's going to make it not continuous when I'm dealing with this problem?
Having a 0 on it. Making it.
Well, I'm dealing with tangent. What does tangent's graph have in it? It has asymptotes. So I need to find out where the asymptotes are to this graph. So how do I find asymptotes if I'm dealing with tangent?
Pi over b.
I need to start out with pi over b to get my period. So pi over b in this case is what? Pi over 10. Okay? So the best way to do this one is just pi divided by pi over 10, which means I'm dealing with pi times 10 over pi, which means I have 10. What is 10?
I'm confused.
What are you confused about?
By what? How you by all that?
The period for tangent and cotangent is pi over b. B is the number in front of x, which is pi over 10. So it's pi over 10. And instead of dealing with this, I'm just going to think about it like this, because then I can just flip it. The pi's cancel. I end up with 10. So what is 10?
The period.
10 is the period. Now where do I find the asymptotes at?
At half.
It's half. So that means tangent has an asymptote at
5.
5. And how far do I have to go either way to get to the next asymptote?
5.
10. Remember, they're always your period apart. So I'm going to have one at -5, and I'm going to have one at 15. So all I'm looking for is to make sure that those asymptotes aren't where?
On our point.
Between 1 and 4. Do I have an asymptote between 1 and 4?
No.
So what does that tell me about this graph between 1 and 4?
It's continuous.
It's continuous. So I know it's continuous. So now I have everything I need to write my statement. So help me with the statement. You got to have this memorized.
Since f of x is continuous,
You can put CONT period.
and f
Nope. You got to say something else about continuous, because it's not always
At
continuous.
the
Let me get
point
the
1,
info.
4.
On the interval, and it has to be the closed interval. Okay. And
F of
4 is less than 0, which is less than f of
okay, and I'm gonna give you another option that might be easier. Instead of writing that out, why don't you? Is it simpler to say that 0 is between f of 1 and f of 4? Do you like that better, or do you like putting the arrows in there?
I prefer the
Because I think that's
Can we
easier.
write it both ways? Like,
You
can
need to
write
choose
it
one or
up
the
there
Oh,
both
will I do
ways?
both ways? Yes,
Yes.
that's fine.
Thank you.
And 0 is between f of 1 and f of 4. Or you could say and, let's see, which one's smaller? F of 1 is less than 0, which is less than f of 4. So this right here and this right here are saying the same thing. It's whichever way you like to do it. Okay, and then we get to there exists. What exists? There exists a C on what? The open interval 1 to 4, such that what? F of C equals 0.
And we have to have that memorized by tomorrow's test. Okay.
On number 94, it has f of c equaling 6. Would you, when you wrote that statement, would you
Yeah.
write it down?
The only thing that changes is that changes and that changes.
Okay.
Yes. Everybody hear her question? Her question, yeah. On 94, we're interested in getting a y value of 6. On this problem, we're interested in getting a y value of 0. So all I do is take the 0 out and put 6 in its place. Okay? Any questions on this before we jump to 94? All right, let's look at 94. So on 94, I have f of x equals x squared plus x over x minus 1. And my interval is 5/2 4. And I'm trying to get a 6. Is that right? I'm trying to get 6. So what's the first step? Find the function values. So I want f of 5/2 and I want f of 4. So plug in 5/2, that's 25 over 4 plus 5 over 2, and then that is 5 over 2 minus 1. So what do I need to do that will help me simplify that? Which is 4. So multiply everything by 4. So that gives me 25 plus 10 over 10 minus 4. Any questions where I got 25, 10, 10, and 4? Try to see where those numbers came from. Nope. Okay, when I take 4 times 25 over 4, what happens? The 4's cancel and it stays 25. When I take 4 times this, 4 reduces and gives me 2. 2 times 5 gives me the 10. On the bottom, same thing happens with this 5 halves. Gives me the 10, and then 4 times 1 gives me 4. So we end up with 35 over 6. Okay, on the other one, that's going to be 16 plus 4 over 4 minus 1, which is 20 over 3. Okay? 20 over 3 is just less than what?
7.
7. It's just less than 7, so that one is just less than 7. And this one right here is just less than 6. Okay, so if I've got something that's just less than 6 and just less than 7, that means what's in between? 6 is in between. Okay? Now, before we write our statement, what else do we need to consider?
Is it continuous?
Is it continuous? Okay? Looking at that equation or that function, where's the only place that is not continuous?
1.
It's not continuous at 1. So is 1 in my interval?
No.
No, so that means we're good to go and we're ready to write our statement. So how does it start?
Since f of x is continuous.
Since f of x is continuous on
The closed interval.
the closed interval, 5 halves to 4, and
And 0 is between.
not 0.
Why
and
is
6.
why is it only halfway?
Oh, it should be.
closed?
Sorry, thank you
Okay.
for noticing that. Okay, and what? 6 is between
5 half and 4. Oh wait, no, f of.
f of 5 halves and f of 4. There exists a c on what?
The open interval.
The open interval, such that what?
C, f of c equals 6.
F of c equals 6. Okay, so there's kind of 4 parts. I would remember that statement in 4 parts. What's the first part?
Continuous.
Continuous on the closed interval. Okay, the second part, we're between. The third part exists on the open, and then you're just stating what they want you to say. Okay, so that's what's going on in those problems. All right, let's jump to the review. And let's go page by page. All right, so questions on the first page of the review, 1 through 9. Any questions on that?
7.
7. Limit as x approaches 0 of x over sine of 3x. Alright? So, number one rule on finding a limit,
Plug it in.
plug it in. Okay, what happens when I plug it in?
0.
0.
It's 0 over 0, and since I'm dealing with a trig function, my 2 options are
Sine x plus x.
a special trig limit or manipulate it. And in this case, since I've already got sine, and there's an x in the problem already, I'm dealing with sine x over x. Now, in order for sine x over x or x over sine x to work, what has to be true?
That must be approaching.
I've got to be approaching 0, but with what I'm looking at, what must be true? That's not true in this case.
It has to be by itself.
They have to be
There's
the
no
same,
subtraction.
Very good. This and this must be the same. And right now they're not. But what can I do to make them the same? I can multiply by 3 over 3. Okay? Now, this part right here is the same, so that limit of that part that I have boxed in is 1, and then I just multiply it times what's on the outside. So what do we end up with? We end up with 1/3.
Okay, can you say that one more time? Like,
You gotta make sure these are the same.
right.
They initially weren't the same, so that means I need to stick 3 on the top. And if I stick something on the top, I have to stick something on the bottom as well, because I'm only allowed to multiply by 1.
I think
So, once they match, then this is 1, and then I just multiply by the coefficient that's out front.
got it.
So we end up with 1/3. Anything else on page 1?
On the piecewise functions,
Yes.
like on number 9, when you set it up, is it x? Like I know how to set up the first part of each, but then on the second part,
It's
is it?
always what's inside greater than or equal to 0, and what's inside less than 0.
So it'd be like x minus 3.
Greater than or equal to 0 for the top, and x minus 3 less than 0 for the bottom.
Okay, thank you.
Alright, second page. Oops, I gotta put this together, right? Alright, 10 to 18. Questions on 10 to 18? 15? On 15, we have limit as we approach 0 from the left. And we're dealing with 2 plus 5 over x. Okay, so number one rule and finding a limit. Plug in, what happens when I plug in?
Number over here.
I get a number over 0, which means I'm dealing with an asymptote. So technically, this limit does not exist. But we're going to go ahead and say it's going to, and then we want to figure it out. So to figure out where it's going, it is 0 from the left. So I think about a number just to the left. I don't have to pick an actual number out. And I plug that in, and all I'm determining is whether or not it's positive or negative. So if I take a number to the left of 0 and I plug it in for x, does it make that fraction positive or negative? Negative, because everything to the left of 0 is negative. So that means this thing is going to negative infinity. So when you're doing a limit problem and you end up at an asymptote, I want you to tell me it's D and E, and then I want you to tell me where it's going. And that's how you figure it out.
And then if we can't figure out where it's going, we just put D and E.
If it's going, like in this case, it's one-sided. If it's always one-sided, you're going to be able to tell. If
Okay.
it's two-sided and we're going to different places, then it's just D and E. Anything else 10 to 18?
Can we do C
16?
on 18?
C on 18, okay. Let's do 16 real quick. So x plus 3, 1 over x plus 1 over 3, is that right? And we are approaching negative 3. So number one rule is plug it in. I plug in negative 3 at the top, I get 0. I plug in negative 3 at the bottom, I get 0. So which situation is this? Fraction within a fraction, so I need to multiply by the common denominator, which is 3x. Okay, leave the top alone, make it x plus 3 times 3x. In the bottom, I end up with 3 plus x. Once we do that step, what should happen? Something should cancel, which it does. So that leaves me with 3x, and what do we always do after we cancel? Plug in, so I get negative 9. Okay, which one did you want, Lainey? Part C?
Yes, please.
Okay, so I have x cubed minus x over minus 1. Okay, so we want a function that agrees with g of x, except at one point. So what they're wanting you to do on this is they're wanting you to factor and cancel. So what's the only thing that's going to be able to cancel? The x is going to cancel. So what can I do to factor the numerator? Take an x out, which makes it x squared minus 1. And then what do I do to the x squared minus 1? Factor it. Then we see we have something to cancel. Once I cancel it, then I have my new function.
So that's your answer with
So
G
this
of
right
x
here, this right here is my new function. This function and this function are exactly the same, except what's the one difference?
is how many
Right, but what's the difference in the graph? I got rid of the hole. The one down here doesn't have a hole, this one does. They look exactly the same, except this one has a hole and this one doesn't. That's the only difference.
Okay.
Okay, and then 19 to 27. Questions on 19 to 27.
There's a lot of material.
Wait, repeat what?
27.
Yeah.
The rest of it. 20. F of x equals 1 over x plus 1, g of x equals x squared plus 5, x squared minus 5. So it wants me to find f of g of x. So how do I find f of g of x?
G of x.
Plug g into f, and when I do that, I get 1 over x squared minus 4, correct? And then it wants me to figure out where this thing is continuous. And in order to figure out where it's continuous, I first must figure out where it's discontinuous. And if I'm dealing with a fraction, what makes it discontinuous?
What makes it 0?
What makes it 0? So I need to factor this. And now we can see what makes it 0. So, it's discontinuous at 2 and negative 2, which means it's continuous everywhere else. So my intervals would be negative infinity to negative 2, negative 2 to 2, 2 to infinity.
And on these, you'll never use brackets, right? Or
Yeah.
almost never.
Right, yeah, principles are fine.
We can do 19.
19. Alright, on 19 I have x minus 3 over 2x cubed minus 6x squared plus x minus 3. Okay, so I need to figure out where this thing is discontinuous and whether or not it's removable or non-removable. Okay, so I need to factor that long thing, but we're not very good at factoring that. But what are we banking on is happening in this problem?
Has a gap at 3.
At x minus 3 is probably a discontinuity. So I want to divide this by x minus 3. So I've got two options. What are my two options on division? Long division and synthetic division. Which one do you guys like? Synthetic? So what's in my box?
33.
3, so then I have 2, negative 6, 1, and negative 3. Bring it down. That gives me 6, which is 0, which is 0, which is 1, and 3.
Good morning, Titans. Please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please pause for a moment of silence. Thank you, Titans. You may be seated. Academic jacket recipients, remember we will be getting sizes for your jackets on Wednesday. We will call you out of class as we need you, and you will report directly to the library. Those of you at concurrent first and second periods, stop by the library as soon as you get to school tomorrow. From Mr. Johnson about your lanyards, all students must wear lanyards with ID at all times. You must have it to leave at lunch. You also will need your ID for Friday night's football game. So I know some of you are already making a habit of leaving it in your locker. Friday night's football game will be closed to Midwest City and Carl Albert students only, so you must have your student ID with you to get into the game Friday night. You don't have to wear your lanyard, but you do have to have your ID. From Coach Sandersfeld for volleyball, congratulations to our JV volleyball girls for taking second place in your tournament this weekend. These girls worked hard all day and we're so proud of them. Nice job, ladies. Attention freshmen, do you have Titan spirit? Do you have leadership skills? Do you want to be a part of the best student council in the state? If you answered yes to these questions, you need to run for student council executive board as a freshman delegate. Stop by Ms. Dozier's room, which is A114 ASAP, and pick up an application. Application deadline is this Friday, September 12th. Elections will be held Tuesday, September 16th during both lunches. Remember, today is the French Club meeting. It will be during second lunch and after school in room A214. So first lunch people, you do not get to skip your fourth period. You go after school to room A214. You do not need to be in a French class to join French Club. From Ms. Bryant for Honor Society. Attention all current National Honor Society members. There is a meeting in the library tomorrow morning at 7:15. This is for all people who were inducted in Honor Society last year. Any students who qualify for NHS will be receiving prospective membership paperwork in a few weeks. Girls basketball. Any girl that is playing basketball this year will need to meet in room A117 at the beginning of the hour on Wednesday so they can order their gear for this year. All girls in volleyball, cross country, and softball will go first so they can get to their other sport. From Coach Golf, all boys golf need to come by Coach Golf's room to vote for homecoming royalty. From Ms. Sandersfeld for the junior class, congratulations to this year's junior class officers. Alex McBride is president, Tori Hartman vice president, Jordan Callies and Julie Morrison are secretaries, and Kaylee Kelpine is the treasurer. Please plan on attending our first meeting this Thursday, September 11th at 7:10 in the morning in room A207.
Typically.
Attention CA Nation, think you have a CA t-shirt for every sport and organization offered at CA? Think again. Bet you don't have a Carl or academic t-shirt. Remedy that life now. Order a t-shirt to support your academic team. Order them through Ms. Beasley in room A201 or any academic team member. They're only $10. Get your CA Apple Pie academic t-shirt and complete your collection. And a very special happy birthday to the following: Frederick Brett, Brittany Cornett, and Christian Traylor. I think you all have a great birthday, and everybody have a great day today. Thank you, guys.
Alright, so you divide this 2x squared plus 1 can never be 0. This is the only thing that can be 0. Since it cancels out, that means it is removable. If it doesn't cancel, that means it's non-removable. Okay? I'll be here in the morning as usual if you want to come in and get some things cleaned up. But make sure you study the review. Test is very similar to the review as always.